All right, let's dive right in and take a close look at one of the most incredible features of human biology, the color of your eyes.
But let me just start by asking you something that it might just change how you see yourself in the mirror from now on. What if that color you see in your eyes isn't really there at all?
Because, for most of us, eye color isn't a pigment, not like paint on a canvas. It's actually a dynamic event. It's an architectural marvel where physics and light are telling a story every single time someone looks at you.
See, every eye color out there is basically the result of two competing forces. You've got pigment on one side, that's the chemistry, the actual dye in your iris, which is mostly melanin, and on the other side you've got structure. That's the physics, the microscopic design of your iris that literally scatters and bends light. Your unique eye color? It's just the result of how those two things decide to play together.
So, let's start by just tearing down what we think we know. First up, we're tackling the color illusion.
But to really understand that illusion, we have to start at the beginning, with the baseline, nature's original design. So let's get into the science of brown eyes, which for most of human history was pretty much the only eye color.
And there's a really good reason for that. Functionally, brown eyes are nature's original sunglasses. Seriously, they were engineered for survival, especially in parts of the world with really intense, bright sunlight.
The biology behind this is just fascinating. So the iris has two main layers. In brown eyes, both the layer in the back and the one in the front, called the stroma, are absolutely packed with a dark pigment called eumelanin. And this isn't just for show, it's a legitimate biological shield.
So the process is simple, but it's incredibly effective. When light hits the eye, all that dense melanin in the stroma acts like a little black hole for light. It just soaks up the vast majority of it, so almost no light bounces back out. The reason the eye looks dark is because it's literally swallowing the light, protecting the super delicate retina from UV damage. Pretty smart, right?
Okay, now this is where the story gets a major plot twist. We're going to leave the world of pigment behind and step right into the world of pure physics with blue and gray eyes. It's all a trick of the light.
So listen, if you only take one thing away from this whole explainer, let it be this. There is no blue pigment in the human eye. None. Zero, zilch. Blue eyes are a complete and total optical illusion.
It's an effect called Rayleigh scattering. So in a blue eye, that front layer of the iris has almost no melanin at all. Instead, it's full of these tiny microscopic collagen fibers. When sunlight comes in, the shorter, high-energy blue light waves smack into these fibers and just scatter everywhere, reflecting right back at you. It is the exact same reason the sky looks blue. Your eyes are playing the same beautiful magic trick as our own atmosphere.
Now, gray eyes use a similar trick, but they follow a slightly different set of physical rules called mesoscattering. In this case, the collagen fibers in that front layer are a bit larger, a bit chunkier. And these bigger particles don't just scatter the blue light, they scatter all the wavelengths, red, green, and blue, pretty much equally. And what happens when you mix all the colors of light? You get white, or in this case, a soft gray.
And this quote just illustrates it perfectly. A blue eye is like the sky, right? But a gray eye is structurally a microscopic cloud. It's the same idea. The tiny particles in the air give you a blue sky. The bigger water droplets in a cloud give you a white or gray one. It's the same physics, just happening right inside your eye.
So we've covered pure pigment and pure physics. But what happens when nature decides to be an artist and mix the two? Well, that brings us to the beautiful complexity of green and hazel eyes.
First up, green eyes. These are a true statistical masterpiece. They're only found in about 2% of the entire world's population, and their rarity is all because of their incredibly specific, almost impossible recipe. So the recipe for green has to be just right. First, you need the physics of a blue eye, that Rayleigh scattering creating a base of structural blue light. But then, nature layers on top of that just a tiny amount of a yellowish pigment called lipochrome. And, as any artist knows, when you mix blue light with a yellow pigment, what do you get? You perceive green.
Hazel eyes are even more complex, often looking like a little starburst. The color isn't spread out evenly at all. You've got a concentration of that brown eumelanin pigment right near the pupil, which absorbs light. But then the outer ring has very low melanin, which scatters light. Then you add a dash of that yellow lipochrome pigment and you get a total shapeshifter, an eye that can look brown or gold or green, depending completely on how the light is hitting.
And finally, let's talk about the true outliers, the anomalies that are the rarest of the rare, amber and red eyes. Now, unlike almost all the others, amber eyes are not a trick of the light. They have this solid, uniform golden color because they're absolutely packed with that yellow pigment, lipochrome. It's a true chemical color. Red eyes, on the other hand, happen when there's almost no melanin at all, which makes the iris basically see-through. The red that you're seeing is actually light bouncing off the blood vessels at the very back of the eye.
Okay, so let's bring all of this together. Let's synthesize all these different pieces. What is the real story being told in your eyes?
This table just lays it all out so perfectly. You've got brown eyes, all about absorption. Their nature is sunglasses. Then blue and gray, all about scattering, the sky you can wear, and a microscopic cloud. Green and hazel are those incredible hybrids, the plot twist and the shapeshifter. And finally, amber, which is pure chemical reflection, like bottled sunlight. Each one tells a totally unique story of physics and chemistry.
So, I think the ultimate takeaway here is this. Your eye color isn't some fixed, painted-on thing. It is a living, breathing, dynamic interaction. It's a constant conversation happening between your genes, the wild and intricate architecture of your iris, and the light from the world that is flowing through you at every moment.
And that kind of leaves us with one last thing to think about. We spend our whole lives looking out at the world. But now you know, the world is also looking back. So what story does the light tell when it looks through your eyes?